Hi guys, welcome to another LER electronics repair video. So in this video I'm going to look at MilliOhm or MicroOhm meters. These are low resistance meters intended to be used for short circuit finding. So I bought, at my own expense I will add, two of these meters from AliExpress. This one, the Vici VC480C Plus, I've seen a few reviews and mentions of these, and they seem to be getting a rather favourable feedback. Yeah, this one is a smaller one, which was the YR2050, and I haven't seen any reviews of this meter. But they've been mentioned on Badcap's forum, and they're considerably cheaper than this one. So, although I only need one, but I ordered two to entertain you guys, to make this video. And I'm going to see if we can figure out whether or not it's worth paying the extra for this one compared with this one, and whether buying anything more expensive would give us anything that this one doesn't do. You know, is there any reason to spend more money? So I'll just show you these, which I bought on AliExpress, and I can just show you what they actually cost me. So we'll just go over to the desktop one moment. So this is the YC, yeah, the bigger one, the more expensive one, Vici VC480C Plus. And this actually cost me €78.50, including shipping. However, I will say that I paid about €8.50 extra shipping on this one to get it here about 3 weeks quicker. So that would have been €70 if I didn't pay the extra shipping. The other one, we can just have a quick look in comparison. So the other one is this one, YR2050. And this one cost me €36.85 plus a bit of postage, was $44.58. Okay, so that's the two items which I actually bought. So one is not half the price of the other, but you know, there is a considerable difference in price of these two items. I used this one a little bit on a previous video, but we'll do a proper review of it now. And this one only arrived yesterday. I haven't even really looked at this one yet. So let's look at this one first. So this is the Vici 480C Plus. And the first thing I noticed with this is quite a lot bigger than I actually thought it was going to be for a MilliOhm meter. Okay. Just take this. Comes with a cover. It comes with like some sort of like shoulder strap, I guess, for using on site. I don't need that. It comes with an instruction book. Yeah, if we can call it. It comes with an instruction book in English. Let's just zoom it down a little bit. So this is the instruction book in English, which isn't particularly well produced, shall we say. Yeah, this is it. It takes 6 AA size batteries, which you remove the cover. I've already put the batteries in this one. The battery holder actually with old 8 batteries, but there's only metal terminals there for 6 of them, so you put 6 batteries in. And I believe this also takes, also it mentions in the book, it's actually you can plug an external power supply into it. Also it says. It mentions it here. I've seen in the instructions somewhere about an external power supply. But yeah, connecting an AC adapter, yeah. But I'm not sure where that actually goes. Without reading the book, where's it? That's just where the screw goes. Okay. Supposedly an AC adapter plugs into that somewhere. Oh, number 9. Oh, let's look at this stuff. Huh. Okay, so number 9 is the AC adapter, and here's the picture. Oh yeah, number 9. Oh, okay. We have it. So there's like a little cover on here. Yeah, we can take the cover off. We can put an AC adapter in. AC 9 volts. But I have it running on batteries. So that's that one. Now I haven't looked at the instructions for this. There's another little little book as well, but this is completely in Chinese, yeah. But I do know a little bit about these type of meters, having used them in the 1980s. I've never owned one myself. So this comes with these two funny looking chunky clips, yeah, and each one has got two wires on, and you'll see here, so it's marked -I -V, and in red it's not so clear on the camera, or even looking at it, +V and +I, yeah. So your two black leads going to the -I -V, doesn't matter which way round because you're both connected together here, and the two red leads -I V plus go to here. Now the whole point of this arrangement is the plus and minus I, that's the current. So when you're measuring a resistor, you pass a current through that resistor, and by measuring effectively the voltage dropped across the resistor at that current, yeah, R equals V over I, resistance equals volts over amps, from that you can work out what the actual resistance is, and that's how they do it. But the problem with that is when you pass the current through the resistor down the cable also has some resistance, albeit low, it has some resistance. So when you measure the resistance, you don't actually know, when this calculates the voltage drop across the resistor, how much of that voltage is actually dropped across the resistor and how much of it is lost down the cables. Yeah? And effectively, the lower the value resistor, the higher the current that flows, the worse the error becomes. Plus, the value of the resistor compared to the value of the cable becomes closer together. So that's two reasons why with low resistances you lose accuracy. So the way this works, same thing, you pass the current through the resistor to actually measure the voltage across it. But the other two wires, the V wires, these actually measure the voltage at the end here, not the voltage at the meter. So because of that, and because of the fact that the sensor that's measuring the voltage is not sending any current, so on the voltage sensing wires there is practically zero current flowing through this, no matter how low the resistance. So you might have, you know, milliamps or even hundreds of milliamps going down the current wires, but probably microamps if that coming up this on the sensor, yeah. So basically, because there's no current in the voltage sensing wires, the resistance of the wires is irrelevant. It basically neutralizes the resistance in the wires, and that's why we have four wires. And both meters, by the way, here have the same method of connection. So let's have a look at this one. It has one knob that selects the resistance range from 2K down to 20 milliohms. Okay. It has a light button, a zero adjust and a hold, and that's the only controls on the meter. So we can switch it on. It's nice and bright. I mean, the light came on. I'm not sure if you can switch the light off. Yes, you can switch the light off. You can switch the light on. Nice bright display, and it's set at the moment I'm on the most sensitive range, which is 20 milliohms. So if we connect these two together, yeah, we can read the resistance, and we can actually now adjust this. So we can set this to 0. It's a little bit fiddly because it's like just a potentiometer, but let me see how easy it is to set this down to 0. There, yeah, I've got that pretty well. So that's now set to 0 milliohms. Now 10 milliohms, which is this scale, sorry, 0.1 of a milliohm, which is this scale, is 10 microohms. So this meter can actually read with an accuracy of 10 microohms, yeah? That's the resolution of the meter. 10 microohms is the minimum resistance it can actually measure and tell you that's 10 microohms. And you can see that is, to me, is very stable. So it's sitting there, they're connected together, it's not wandering around, it's very stable. I'm going to do some experiments shortly with both of these meters, but now I'm just going to show you an excerpt of a video I made earlier this week, which is not published yet because I'm waiting for parts to repair an all-in-one computer. But I actually used this to trace a short circuit on it, and I think this is a very, very good indication of what this meter actually can do in a real life repair situation. So here's our data sheet, and there'll be a typical application on here somewhere. There's a pin out, that's useful. So this seems to be the way round we've got it. Pin 4 is ground, pin 8 is V in. Power input, yeah, 4.5 to 36 volts. I'm sure what was burnt up was a resistor that feeds to here from the 19 volts. So it's a low value resistor, possibly even a 0 ohm resistor that's burnt up. So what we need to do now is figure out why we've got a short from V in 19 volts to ground here. So let's see if we can find out where that short actually is. And I'm going to use the low ohms meter initially to see if it actually will tell me which component is actually short. The other side of this, by the way, is where we saw the coil was connected to SW, was connected to pin 1. Yeah, that's where it went to the coil when I measured it through. So that's correct. And I don't think there's a short from here to ground, but I will just check. But I checked all the coils earlier and there wasn't. So it appears that the short is either inside this chip or on one of the capacitors on the input to this chip. And that's why the resistor burnt up. So that's told us a lot about what's going on here. Probably enough to fix it, actually. So let's go back over to the microscope again. Okay. And let's have another quick look. So just get it back into properly to focus. There. Okay. So we know pin 1 of the chip actually goes to the inductor coil. We measured it. In fact, I think you can even probably see the track comes this way to the coil. And from this coil to ground, there isn't a short. We measured this before. There was no shorts on any of the coils. Yeah, the short is on this side of it, the power into it. Yeah, there. So I'm suspecting one of these capacitors or the chip is the most likely culprit, unless there's something on the other side of the board that I can't see from here. So let's get our low resistance meter and see if it actually will tell us. Because it's so close together, I suspect it probably won't, and I'll probably have to remove these one at a time. But let's just have a look to see if we can actually figure out which of these capacitors is actually short circuit, if that's where the problem is. Okay, so I've got the low resistance meter. And I'm interested to see whether or not this will actually tell us where the short is with these being so close together. So we'll start off with this end. This is the first capacitor. And that's reading 3.97. Now let's go to the next one. That's the reading 3.96. 3.95. That's reading lower. What's this one reading? 3.96. No, actually, I mean, it's 0.396 by the way, 0.398. It's on the chip itself. I'm just going to the chip itself again. 0.397. So the lowest seems to be on this one. 0.395, yeah. 0.397. So it looks like 3,000. It looks like that one is the one that's short, but I'm not sure because it's so close together. This will actually tell us reliably. I mean, we could stick 12 volts or 19 volts in here and just see what gets hot. I mean, that's quite a feasible way to do this. But let's just try. Let's see if we can remove that middle one and see if that really is actually the short. See if the MilliOhm meter actually did tell us which one it was. Okay, so I've removed that one capacitor. Let's see if this actually did tell us which capacitor was short. So has the short circuit gone now? And yes, it looks like it has actually. Let's get the normal ohms meter. Let's just double check that. But it looks like it actually told us which capacitor was the short circuit one, even though they were so, you know, they were right next to each other. Let's have a quick look. So go to ground. So one side is ground anyway, and the other side now isn't short anymore. Ah, yeah, you can see. So yeah, that MilliOhm meter actually told me which side of the capacitor was short without injecting any voltage into it. That's pretty impressive. I think you'll agree then that that really was an excellent demonstration of just what this thing can do. Yeah. and that's without reading any instructions. First time I've really used it on a short circuit like that, and that's what it did. Another thing I've noticed with this meter, by the way, is that if I just short us back together again, this is several minutes. I was just getting the other video together, and you'll notice that this thing basically will zero itself back. Yeah, it's very stable, and I like that. Now, obviously, I can't make that same test with the other meter because I've now removed the capacitor from that board. So shortly on this video, I'm actually going to mock up a short circuit on a board with like a bank of capacitors and see if this meter will do it again and see how the other one performs. But in the meantime, let's actually have a look at the other meter. So this is this one, YR or something. Not diarrhea. No. I hope it isn't shite. Sorry, I couldn't resist that one. YR. Okay, and that's this meter. So we can open this one and let's see what we've got. So the first thing we've got is an instruction manual, which is, it's encrypted in Chinese. Yeah. No, sorry. Somebody's going to tell me off for that. We've got an instruction manual, and it's encrypted in Cantonese. Yeah, well, it could be Szechuan. It's encrypted in Cantonese, as far as I say. No, it's simplified Chinese. Somebody's told me this before. People speak dialects, but they all write in Chinese. Okay, it's encrypted in Chinese. Either way, I can't read the damn thing. Yeah. We have a wire. Yeah. And we have our little meter. Okay. And that's what's in the box. Nothing else in there. No, that's it. That's what comes with this one. A little protective film on it. So let's take this off. And let's have a look at this. So this is the meter. First thing I noticed with this, it actually comes with battery already installed, whereas you like to install batteries. And that surprises me a little bit because generally speaking, in the air freight, there's no batteries. Yeah, it's saying the same range, 0.01 milliohms up to 1k. The other one goes to 2k, but I don't think the high end of the resistance is that important. I think really we want this for low resistance measurement. 5 volts, more than half an amp. Yeah, and this has a micro USB, which I haven't tried. I'll try it in a minute to see what that actually does. I think I have a lead that fits that. So maybe this connects to the computer. So I've got it switched on, and let's have a little play with this. So in this case, I can't read the instruction manual. Maybe somebody else on here can read Chinese. So let me have a look see if I can figure out how this thing actually works. Well, the first thing that I'll say, it's the same sort of setup, yeah. So it comes with these funny little clips, but they appear to be like a cheaper version of this one. Like the plastic, like doesn't feel as solid, and the wires are much thinner. Okay, but because this again is a 4-lead meter, this is called a Kelvin probe, by the way. The thing with two wires on. Because it's a 4-wire, the thin wires shouldn't make any difference because, again, when it's measuring the voltage drop across the resistance, it's used on the 2 separate wires where there's no current flowing. So the resistance of the wires really should have no effect whatsoever on the reading. So having thinner wires doesn't particularly bother me. This has a little USB connector, which is a bit, it's not very solid. I'm not sure how long that would last actually, but anyway, okay, it has a USB. And USB plugs we can get, so we can fix this easy enough if it goes wrong. So we have 6 buttons and a set of instructions encrypted in Chinese. So this is your power button. Oh, it also switches the lights on and off. And I'm guessing this is saying yes and no, and there's like 2. Yeah, shut down, yes. Yeah, those must have failed. So one press actually turns it on, and it's saying something in Chinese. And the light's on. Okay, the light's on. This says hold, it actually says hold in English. It's got a battery reading on this, which the other one wasn't giving me. So this is what I do. Ah, this is selecting range, 100 ohms, 1K, auto. Ah, this has auto ranging, whereas the other meter does not have auto ranging on. Let's just try, let's press a few more buttons. So that seems to set the range, yeah. That doesn't appear to do anything. That makes a bleep, yeah. This one probably gives a message saying, do not press this button. And then probably gives you another one saying, do not press this button again. That doesn't seem to do anything. That doesn't seem to do anything. Let's switch off auto ranging. 1 ohm. No. I've got a feeling this has a hold function. You can perhaps scroll through the results or something like that. Let's have a look. So we'll just untangle our wires. Oh, the light's gone off, but fair enough. That's not. Oh! Now I've got some weird menu that I can go up and down, but actually means nothing to me whatsoever. This seriously could do with some instructions or an English menu. I do believe there's other firmware for these meters on IFPFZHDO blog. Yeah, if there is, I'll link them on this video. But for now, let's just play with this thing as it came out of the box. Yeah. How do I get out of that menu without like accidentally doing anything? This is a good question. I don't know, because I don't know what it selects, so I just don't know what it does. And now I'm a bit like loath to press anything. Yeah. How did that menu come up? It came up by pressing this. Yeah. That gives you a menu or not. What happens if you hold this? Oh, that's the on or off. I guess you didn't know. Well, this was hold, but I think this is holding the results. Anyway, look, I've messed with it. Let's connect the wires together. Well, it's going down. It's gone to the 1 ohm range. I'm assuming it did that automatically. And it's going down to 00004. So that's the same resolution. Now, can we switch the light on? Can we zero this? Hold. 10 ohm. Well, this is selecting the range, you can see it. I don't see any obvious way to zero it. I mean, it's not far off, I will say. But I don't see any obvious way to zero it. I also will notice, and I've got to say this is wandering around a little bit where the other one isn't wandering around a little bit, yeah? So that's the two things I notice. So let's now see if we can actually mock up a short circuit on the board. And let's try using both these devices and see, or try and do something similar with a short circuit capacitor if I can, and see whether or not it will find it. I've got a scrap GPU here, and I've fabricated a short circuit. So what we have, this is the main VRMs. There's actually no GPU on this. It is a donor board. So these 3 banks of 4 capacitors are all connected together. That's actually on a different rail. But these 3 are all connected together. So we've got 12 capacitors, and probably these little ones as well for that matter, all on the same voltage rail. So I've fabricated a short here on the middle one. So I'm going to take the Vici VC480C first. And I'm just going to connect the leads together and see if I need to zero it. So just give it a second to settle down, and we can just right, it's on 0. Okay. Now I'm going to now measure. First of all, let's see if we can determine which column of capacitors has the problem. So we'll go to this column first. I'll just measure across the first one. And I'm reading 5 point, it's just settling down. There's probably some capacitors charge on here. 5.6, it's going down a little bit. Let's just give it a second to settle. 5.60, it's close. It's wandering a little bit. Yeah, there we go. 5.45. Let's go on the middle row. So this is the one that actually has the problem. And it's going down to 4.8, so it's clearly reading lower. Yeah, let's go on this one, and that's reading a bit higher. Yeah, so each column is reading differently. Now, so we know it's on this column it's the lowest reading. Is this capacitor also the same column? Yeah, looks like it. So that one's reading 6.6. So let's go to the next capacitor. 4.91. Yeah, next capacitor. Now these probes are a bit awkward. I'm in there. 5.56. This is the one with the short. It's reading 1.9, 1.7, yeah, and then we go to the next one afterwards. And back to 5.5. So that is very, very accurately pinpointing a shorted capacitor in a block of 15, because these little ones are in there as well, yeah. So that machine, if you ask me, works very, very well. Very simple, very intuitive to use. So let's have a look now with the cheap one. Let's see if it actually does the same job. Okay, so this is the other meter, the cheap one, yeah. One thing I noticed with this is the display doesn't stay on for very long, which is good for your batteries, but not very good when you're trying to do the sort of things for videos, yeah. But that won't affect you guys, I bet. Like you see, it's gone off already. It would be nice if it's actually had an option to make that stay on. But let's see if it can actually do the same job. So first of all, let's short it together. So it's reading 0.003. I don't know how to zero this one, but does it matter? Right off again. That's annoying me. So, well, it's gone into auto ranging, gone to 1K, and it's not reading away with, you know, the same range. The first thing I'm going to do with this is try and set it onto manual range. I've set it onto the 1 ohm range now, yeah. Manual. No, it's gone back to 1. No, it's on 1 ohm. It's 1 ohm. Okay. So I'm on the 1 ohm range. Let's see if it will now switch back that body light on. Okay. So that's reading 0.0063 on that column. Sorry for my frustration with that, guys. I know it won't affect you guys. But this row is reading 0.0010. This row it's gone to 1K on its own again. 1 ohm. I've selected the range. Maybe it's something to do with the way I'm turning the light on and off. Switch the light on. Yeah, it does. No, it gives you the menu. We don't want that. Right, okay. I'm struggling to get the light to stay on at the same time I'm actually taking the measurements. 0.008. Yeah. 0.006. I hope you can see it because I can't get it to stay on. 0.006 again. Let's have another look. It's gone to 10 ohms. So this is switching the light on and off, but it's also switching the range. Okay, I can tell you guys now, this thing's useless to me for the YouTube, I think, but that is not something that will affect you guys. I've now got it lying on its back, and I'm hoping it'll actually give me a stable reading now without the light on, so you can actually see what it's doing. So again, let's go to the first row of 4, 5, and it's reading 0.0061, okay? This is the row that has the problem. 0043. Go to this row. 0081. So it's definitely telling us that this one is where the problem is. Yeah, it's definitely reading lower than the other two, but not as definitively. We've gone back on this one now. 5.3. 5.47. It doesn't seem to be anywhere near as stable. You know what, guys? I don't think I can actually use this to do the job. 0.005. Go to the next one. 0.006. This is the one with the short. yeah, it's definitely reading that one lower. It's definitely reading that one lower. Yeah, I'm just going back to it again. Well, I've got a 003 out of that one now. Yeah. Okay. I'm going to put that down as kinda. It kinda does it. But I'm not impressed with the stability of this. I can't seem to get repeatedly the same results like I can with the other meter. Okay, the thing with the display lights going off, that's not going to affect most people. It was completely frustrating me, but it's not going to affect most people. I'll give it that. It doesn't seem to like to stay on the range properly when you manually select it. It changes its mind and moves the decimal point. That's another thing I don't particularly like about it. I have heard there's other firmware for this, and maybe I'll try a firmware update and see if it actually then functions, and I'll do another video. One other thing I'll just mention about using meters. This is quite interesting. So this thing, and I'm sure both of them are quite capable of measuring the resistance of an inductor coil, buck regulator coil. So if you've got a short on one side of the coil, I'm sure both of these were quite capable of telling you which side, because if we go across a buck coil with this, I get a reading, yeah, 0.140. You'd expect them to be the same, wouldn't you? 0.17, because they're basically the same component. 0.170. Go back to this one again. 0.140. Let's see what the other one does. Let's see what the Vici does again. I'll just have to get the camera where you can see it one moment. Okay, so we're back with the Vici VC480C again. Let's just do the same thing with this. Let's just check how it reads some inductor coils. So yeah, it's reading 2.5, 2.4. There will be capacitors charging on these boards, so it probably takes a little while just to stabilise. But yeah, this thing obviously sees an inductor as a resistor, which is what you'd expect it to do, and they're all reading about the same. Okay, I think that's enough tests then to come to a conclusion with these. Just before we come to the conclusion with this then, I actually slightly got the pricing wrong on these, so I'll just clarify what I actually did pay for these items. The YR2050, this was the actual price of the item listed on AliExpress. I paid postage on top, but then I get a deduction for tax because this included IVA at 21%. So I actually paid $36.85 for this meter. That's the cheaper one. That's what I actually paid in euros. Call it 37 euros as a close estimate. So that's why I actually paid for that one. And the Vici, I just have to find another page. So yeah, this one cost me, actually that's the amount I paid, $75.58. So that was a listed price, plus I paid express postage on this one, less the tax, which is automatically added and deducted. So I paid 75. So 37 to 75, I effectively paid double for one than I paid for the other one. And that, you know, that's a difference. But in my honest opinion, would I pay 37 euros and buy this one again if I knew what it was like, or would I have bought it if I knew what it was like? And I think the answer is no. This one at twice the price, I think it's worth that and more. I honestly do. I love this bit of equipment. I love its stability. I love its ease of use. Even without a manual, it's very simple to work this one out. And it performs really well. This will do the job, don't get me wrong. It did tell me this was a short circuit capacitor, but there's a lot of going backwards and forwards, and it was very frustrating to use, especially with the lights. Admittedly, it doesn't affect everybody. This one, it's just a fantastic bit of kit. Out of the box, yeah. I mean, I've heard there's better firmware for this, but if you buy something, right, if you buy it, you expect the damn thing to just work properly. You don't buy it and think you just have to then start messing around flashing other firmware into it, yeah. I'm not even going to bother trying what the USB does. because I don't think it gives me any features that I need anyway, to be quite honest, unless it actually gives me a better display for on the videos. Okay, my honest opinion, if you're going to buy one, buy that one. If you're on a budget and you can only afford this one, wait another month until you can afford that one and buy that one. If somebody can recommend any kits or other ways to make a MicroOhm meter cheaper than this, let me know, and I'm happy to buy them, and let's see what they do. Yeah, if somebody knows anything more expensive than this, that is better than this, don't expect me to buy it out of my own pocket, but I would like to know why it's better for my use. It's not the resistance that I need, the accuracy, it's finding the lowest resistance. That's what I need it for. It's what you need it for. You're fixing stuff, you're not designing it, yeah? Okay guys, hope you enjoyed that video. It's the weekend, it's the car boot coming up on Sunday. I'm sure I'll find some more fun stuff. Have a good weekend, and I'll see you all soon now. Adios amigos.